Eric Burgess here, and we've been told to graph the following function. So it's a piecewise function, and we're told that if x is less than or equal to 3, we're going to do this 6 minus x. And if x is greater than 3, then we're going to just be a constant number. We're going to just constantly put 3. So just as a reminder, this first column tells us about what y will be doing, according to whatever x says about it. And this second column tells us about x. It tells us the specific domain that x is in when a certain behavior happens. So let's go ahead and just create an axis. So I'm just going to create one here. And we'll go ahead and try and do this a bit to scale, I suppose. So when x is less than or equal to 3. So here's going to be 3. Here's 3. We want to be graphing this line. So everything on this side, this is all the stuff that's less than 3 or equal to 3. We're going to be doing this equation on this side. So this is just 6 minus x. So whatever x is, it's going to be 6 less than that. So if we add x is 0, we're just going to be at 6. So I'm just going to go ahead and arbitrarily put up here the number 6. Okay? And in fact, I'm actually going to bring that down just so it's a little easier. So I'm going to define 6 to be right there. And we've got a point on this line because this is less than. And we need 2 points to graph a line. So if we put in 3 for this, because 3 is included, there's an equals 2 sign. So 6 minus 3 is just 3. So let's go ahead and 3, that's halfway up to 6. So that's going to be like right here-ish. So I'm going to go ahead and put that right here. And we've got enough to graph a line. Because right in between any 2 points, there we go. That's a pretty good looking line. If you have a ruler, you can just use your ruler. And so this would be our first line. So this is just the top half. And we have a solid dot right where 3 is, because 3, again, you can see there's an equals 2 sign there, is included in the interval. And then it says that for everything after this, it's just a 3. Because if x is bigger than 3, so these are all the numbers that would be x that's bigger than 3, right? X is 5, x is 6, or whatever. And off to infinity, we're just going to have 3. So that means that right here, we're just going to be 3 the entire time, all the way off to positive infinity. But over here, we would be this function off to negative infinity. And so this would be the graph. Now, we could do a couple things to clean this graph up. We should have these little arrows on the end to show it never stops. This is our x-axis, this is our y-axis. And some people are even really nice, and they put down what the function is along these parts. So this is the function y equals 6 minus x, and this is the function y equals 3. And we also have a hole here as well as a dot, right? The hole is for this part. Typically, I just draw the dot, but depending on however you want to show to your instructor that you know that there's no equals to, this isn't included in this part of the interval. It just so happens that these two intervals equal the same thing when we plug 3 in. This becomes 3, and this is always 3. So in this case, it's really just a dot there. But it's this part is technically not included in this interval. We just got lucky with how they kind of just lined up like that. If you have any questions about this, let me know. Subscribe. If you're a Citrus College student, stop by online tutoring. We're there to help you out. And we'll catch you in the next problem.